5.5, number 41. Explain why or why not. So f is symmetric about the line x equals 2. What does that mean? I'm going to draw a picture and show you what it means. So it has symmetry about the line y equals 2. So we'll say 2 is right there. That's going to be a point of symmetry. So anything I draw on the right is going to be reflected to the left of that. So I'm going to just draw some weird function. I don't know. That's what I draw. If I reflect that to the other side, watch this. I think I can, okay, maybe, can I copy? No, it's not going to work. Never mind. I was going to try to copy and paste and flip it, but there's too much stuff there. So if I reflect it, it's going to look something like this. Yeah, close enough. So that is what I have. Then they're saying the integral from 0 to 4. So I'm going to highlight this in red, and I'm going to show the net area of that. 0 to 4 is from here to here. So it's going to be all of that. And they're saying that's equal to what? And then this one I'm going to do in green. 0 to 2. Well, what's 0 to 2? 0 to 2 is going to be this green part. And they're saying if you take 2 of these greens, it's going to equal the red. And that's true because it's symmetric. So that's why it is true for part A. Let's go to part B. And let me explain part B and what's going on. This is where my nightmare started in first period. And now my experience is going to save me from making a fool of myself, hopefully. I did it such a difficult way. So we're going to look at two things, a plus x, a minus x. Now think about that. The center's A, and you're moving right x and left x. Do you all see that? You're at A, one you move right x, one you move left x. So I'm going to pick a random A. We don't know where that is. I'm going to say it's there. And here's what it's saying. From A, if I go right x, so I'll call this A plus x, and we go left x, A minus x, what's the difference between those functions? The only difference is one is positive and one is negative. So that means one of them is up here and the other one's going to be down here. Now, what's really going on here? This has symmetry. Ooh, I didn't draw that right, did I? Two and a half. That's close enough. I have symmetry about the point A. See how it's reflected across? So this statement is saying it's symmetric about A. Because if I move right x, I go up. If I move left x, I go down, and they're same points. So I have symmetry about that point, and it's odd symmetry. It's odd. So whatever's over here is going to be opposite on the left. That's what this is saying. That is hard to see. Takes a while to get your mind around that. So now let's look at what this is. If I integrate left 2 and right 2 from A, here's A. If I go left 2 and right 2, since, okay, I'm going to draw this. It's an odd function symmetric to that. So this might look like this. So if I go left and right and I integrate it, isn't it obvious that the net area is going to be 0? Because that's going to cancel that out. So therefore it's true that that integral is going to be 0. That's crazy. If you didn't get that, understandable, because there's a lot of abstract things going on in part B. That's kind of a tough one to grasp and get your head around. All right, let's go to C and D. Let me erase all this. The wave is coming, so hang in there. It's a long problem. The average value of a linear function on the interval from A to B is the function's value at the midpoint of A and B. Let me draw a picture. I so butchered these problems first period with stupid, dumb things. Okay, the moral to the story. Don't stay up really late cramming for a test because your brain will not function sharply the next day. It's not worth it. You're going to make so many dumb mistakes. Do not stay up too late. You need sleep for your brain to function correctly. Don't stay up all night cramming. You're going to make a lot of dumb things. Okay? So here we go for part C. A linear function is a line. So I'm going to draw a line. And the equation of a line is mx plus b. That's the most general form. And I'm going to integrate from, okay, it says A to B, but I already have B here. So I'm going to change that to C. We're going to go A to C. So we want the net area from A to C. And what are they saying? They're saying that if I take the average value from A to C, that, okay, let me just do that first. Average value from A to C. So the average value, I integrate my function from A to C, and I divide by C minus A. This is going to get crazy. It's going to have a lot of algebra. So hang in here, my friends. Hang in here. Okay. So the antiderivative of that, I add 1 to the x, and then I divide by that same power. And then, that's a b, by the way. The antiderivative of b is bx, and that's from A to C, and that's all over C minus A. Let's keep going. The rule says I plug in C first, so I will do that. mc squared over 2 plus bc. Then I plug in A and I subtract that. So I'm going to plug A here and here. So I'm going to get ma squared over 2 plus ba all over C minus A. And this is craziness. I'm going to distribute that negative and get this mc squared over 2 plus bc minus ma squared over 2 minus ba all over C minus A. This is crazy. I'm going to keep going. More algebra. These look like they should be friends. They look like they should be friends. So I'm going to move them together and let them hang out. So I'm going to get mc squared over 2 minus ma squared over 2. And then I'm left with a bc minus ba all over C minus A. Crazy. Let's keep going. What you should notice, look, they both have an m over 2. And then these both have a b. So I'm going to factor those out. So I'm going to factor out the m over 2. I'm left with c squared minus a squared. And I'm going to take out the b, and I'm left with c minus a, all over C minus A. Let's keep going. This is the difference of two squares, and that's going to factor to C minus A, C plus A. Let's keep going. Watch what happens next. They both have a C minus A. I'm going to take that out because it's a common factor. So if I take the C minus A out, what am I left with? Well, that's gone. So I'm left with m over 2 C minus A, m over 2, C plus A. And if I take that out, I'm left with a minus b all over C minus A. And the beauty, the C minus A's cancel. And all that work to get to the average value of that function, I told you it's a crazy problem. I'm going to distribute that m over 2. I'm going to get m over 2c plus m over 2a minus b. Wow, that's my average value. Crazy. What does this have to do with the problem? C claims that the average value of a linear function, which we just found, equals the function value at the midpoint. Well, what's the midpoint? The midpoint is in the middle here, and the average of two values is a plus c over 2. That's the midpoint. Now, it's telling us that the y value here at that midpoint is equal to this average value here. So let's check it out. We're going to plug this into the equation for x and see what happens. So the y value here is m times a plus c over 2 plus b. Let me distribute the m here and here. ma plus mc over 2 plus b. Let me split these out to two separate fractions. ma over 2 plus mc over 2 plus b. And let's take a look. This is the y value at the midpoint. And looky here, lo and behold, it does equal the average. Wait, minus? No, no. Okay, I see that. No. It's not gonna happen. I'm not gonna make a mistake. No. It's plus. Wait, what happened? Plus, okay. What's going on? I'm not gonna make a mistake. I'm gonna find my mistake. It's not gonna happen. No. Okay, so I distribute the minus. Okay, so this is a minus. That makes sense. I rearranged it, so it's gonna be minus BA, okay? And that's gonna be C minus A. Oh, I see what happened. Look. I found it. See that plus? It should still be a plus there. That still should be a plus. That still should be a plus. That still should be a plus. Bam! No mistake. I didn't make a mistake. I'm good. All right, wow, this is a lot of work. All for part C. We still have part D. Wow, I am tired. That was a long problem. And we're not even done with this problem. Wow, wowzers. Okay, let me erase all this. And we're doing part D. Consider the function on the interval 0 to a. Its average value is 1/2 of its maximum value. Is that true? Let's try this. Okay, I'm going to cheat. I see the answer is false, right? So if I can find one counterexample, I prove that this is false. So I'm going to try one particular point. It has to be, for this to be true, it has to be true for all a. I'm going to pick a equal to 2. So I'm going to show that the average value from 0 to 2 is not 1/2 of the maximum value. So now let me show you what's happening. All the a's are 2. That'll be a 2, that'll be a 2, and that'll be a 2. So I'm going to replace all these a's with 2's. And now do the problem. So f of x will be 2x minus x squared on the interval from 0 to 2. And the average value, I can do that. You integrate from 0 to 2, and then you divide by 2 minus 0. Let's keep going. The antiderivative of 2x is 2x squared over 2. The antiderivative of x squared is x cubed over 3 all over 2. Then I plug in 2. I can do that. 2 squared over 2 minus 2 cubed over 3. Then I plug in 0. If I plug in 0, we can see both those are 0. So that's just 0. And that's all over 2. Let's keep going. That's 8 over 2 minus 8 over 3 over 2. Is that right? I think it is. I'm going to get a common denominator of 6. I'm going to make this 6. So I'm going to multiply by 3 over 3, multiply by 2 over 2. And this will be, what, 24 over 6 minus 16 over 6 over 2, which is going to be 8 over 6 divided by 2, which is 8 over 12, which is 2 over 3, 2/3. 2/3. 2/3. That is my average value. Now I'm going to find the maximum value of this function, and we know how to do that because we are so cool. We are cool like drool. Where do max and mins occur according to chapter 4? Critical points and endpoints. Let's find the critical points. Take the derivative, set it equal to 0, add 2x to both sides, divide both sides by 1. My critical point is at 1. Now I am so smart because I know this is a parabola, and because the minus is upside down, so that critical point is the maximum point. I know that. So I'm going to find f at 1. It's 2 times 1 minus 1, which is 1. Does that match this? No, it does not. Therefore, false. Liar, liar, pants on fire. That statement, part D, is not true. I am done.